Hi, this is Leetcode question count the number of square free subsets, and this is the third question of weekly contest 333. So in this example, we have three square free subsets. The first one is 3, the second one is 5, third one is 3 and 5. Let's take this one. So 3, 5 is square free subset because the product of all of its number equal 15 is not divisible by a square number other than 1. So 15 is not divisible by 4 or 9, so on. Now, how can we solve this problem? The first thing is we need to get prime factors for every number between 2 and 30. For example, the prime factor of 14 are 2 and 7. So these are prime numbers and the product of them is 14. For 18, the prime factors are 2, 3, 3. For 7, 7. Now, how can we know if a subset is a square free subset? For example, if we have 14 and 7, first of all, we get the prime factor of every number in the subset. So for 14, prime factors are 2 and 7. For 7, it's 7. Now, if there is number happen more than once, so 7 and 7 occur more than 1, then that means this is not square free subset. That's because the product of all number in the subset, which is 14 multiplied by 7, and which is also 2 multiplied by 7 multiplied by 7. This is divisible by a square number, 7 multiplied by 7. Another example, if we take a subset like 4, so 4, the prime factors are 2 and 2, and again this is not square free subset because there is a number or there is prime that occur more than one time. So this means 4 is divisible by 2 multiplied by 2, and this is not square free subset. Now, prime factor will be one of these 10 numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So these are 10 prime under 30, and we are going to encode every number prime factors into a mask. So let's say these are the indexes of these prime numbers: 0, 4, 5, 6, 7, 8, 9. So for example, if we have number 14, the prime factors for number 14 are 2 and 7, and to encode this into a mask, so if we have, this is bit 0, this is bit 1, 2, 3, 4, and so on. All the bits are 0. Now at 2 is at index 0, so we set this bit to 1, and 7 is at index 3, we set this to 1, and other are 0, and this means 1001 is the mask for prime factors of 14, and this equal 9. Another example is if we take 6, prime factors of 6 are 2 and 3. 2 is at index 0 and 3 is at index 1. So this means that this value is 3, 1, 1, equal 3 in decimal, and this represents the mask of prime factors of 6. So in this loop here we are assigning masks for every number from 2 to 30. Notice that for number like 4 we have prime factors like 2, 2, so there is duplicate, and this number cannot be part of any square free subset, so we exclude this number using this code. So masks of I equal mask. Now this is a dictionary, maps every number into a mask. As we said, 14 its mask is 9, 6 its mask is 3, for example 2 its mask is 1, and so on. And also mask of 1 is 0. 1 is not prime number, so there is no bit set to 1. Assign the value 0 as a mask. Now let's say we have this array, and we need to calculate the number of square free subset for this array. What we need to do is at every index we need to calculate the number of square free subset for every possible mask, and we use that result to calculate it for the next index, and so on. So we have 10 prime numbers, and this means we have 2 to the power 10 minus 1, and this equal 1, 0, 2, 3 possible masks. And add to this the 0 mask, so we have 1, 0, 2, 4 masks from 0 to 1, 0, 2, 3. So for every mask we calculate the number of square free subset, and we use that in the next index. So assume we did that for this index, for this, for this, for this, and for this. Now to calculate for this value, for this index, for example, we have value 6, and the mask of 6 is a 3, so we have mask 3. Now at this index we iterate over all the masks from 0 to 1, 0, 2, 3, and if the mask and 3 equal 0, this means there is no overlap or no repeated prime factors, and we can append this value to all the potential solution at this mask. Let's take an example. Let's say we have the mask value 4, so we have 3 and the mask and the 4. This is in binary 1, 1, 0 and 1, 0, 0, and this equals 0. This means this is a prime factor, this is prime factor, this is a prime factor, and because of that, so assume at this index for the value 4 we have 10 square free subsets, because the value is 0 here. That means let's say the result at this index 0 1 2 3 4 of which mask. Now the new mask is 1 this or this, so 0 1 1 or 1 0 0, and this equal 1 1 1. This is the value 7, and this means we have these all prime factor. So this value plus equal the 10 came from the 4 plus new 10, because we can append this value 6 to every number here or every solution here without having repeating bits. So this is this value is 20, so 2b of 4 of 7 plus equal 20, and this is what we are doing here. So we check if the mask, which is j, this is the mask, and the mask of a number of I equals 0. This means that we can append this number to this mask's square free subset. dp of I of new mask is j. You can name j as a mask or mask of number of I. This is this value. So we add it to the answer here. Always we move the previous result to the current one, then we do the addition. And here we add only one, and that's because for every number we have, let's say the number 6, the mask is 1 1, and we know already there is no overlap, because in this for loop we filter out all the numbers that have repeated value, like 4 we said prime factors are 2 2, so we filter out it from this dictionary. And so in addition to this value, this addition, we add tb of I for the mask of 6 is 3 plus equal 1, and that's because the subset set itself, the subset 6 itself, this is valid square free subset, and you can have it only on this subset without appending it to any other mask, and this is why we are adding plus here. Now we did this for every number, and at the end here we accumulate the answer for all possible mask, and that will be the answer.